Hi everyone, welcome to another day of graphing reciprocal functions. Your essential question for this set of notes: if given a reciprocal function in standard form, which letter represents the vertical asymptote and which letter represents the horizontal asymptote? For a reciprocal parent function, a parent function means it's the original function where it has no shifts left and right yet. So f of x, remembers that stands for y, is actually our function of 1 over x. So the type of graph that we're going to be graphing is called a hyperbola. So since it doesn't have any shifts, we actually get to start from 0, 0 at the origin, which means that we get to draw a vertical asymptote and a horizontal asymptote. So what asymptotes are is that it's a line, basically a line, imaginary line, that crosses your axes and where your graph will actually never ever be able to go across the asymptote there. So we're going to go ahead and draw those asymptotes so that you guys can see them and make them visible. So since again there is no shifts yet, we actually just get to draw our x and y axis. So when we represent an asymptote, we actually draw dotted lines. If you can't draw the dotted lines, go ahead and take your eraser and kind of erase little sections of it, so now it's dotted. So yeah, this is represented, so this is my vertical asymptote, the one that's on the y-axis. So we get to write y equals 0 for our, y equals 0 for our horizontal, because that's this one, our x-axis. And then our vertical was the x equals 0. So it's going through this, there's a line going through at x equals 0, and there's a line going through at when y equals 0. So our graph, when we go to graph this, is never going to be allowed to actually touch that. So now we get to kind of use this as our rise over run. Think of this as your rise over run. 1 divided by, there's just one x there, and a 1 in front of that x. So our rise is 1 over 1. And again, you start from the origin, that center. So I'm going to go up 1 to the right 1 from our asymptote. Okay, and then, what's nice is that now I get to just draw my graph. This does not ever actually get to touch those asymptotes. And then we go in the same direction this way. We're going to go down 1 to the left 1, because then that gives us our negative value, and negative divided by negative is still a positive, and then we get to go out like this. So this is a hyperbola graph. Now we just need to show our domain and range restrictions. So since we actually have two graphs on here, we're going to have two intervals of our domain. Again, you start from the farthest point left of our graph. So we're coming from the negative side of our x-axis. So we're going to be coming from negative infinity for our first graph, and that is less than, and then you list your actual asymptotes. Well, my asymptotes are at 0, so that helps me define which values my domain and range will go to. So then I have x and this going to 0. Then this is where I can't actually touch the graph. Then all of a sudden at 0 my graph picks up again and starts going over to the positive infinity side. So now we're going to have 0 is less than x, which is less than, it's going over to that positive infinity sign. Now we have our range to talk about. So our range is the lowest point the graph goes to the highest point the graph goes. And again, we have two different graphs that we need to discuss. So it's coming from the lowest value, so we are going to have a negative infinity less than, and don't forget to use y for your range, and it's going up to our next asymptote. So remember, we can't have a 0 right here, so we look at the y value and we see that it's at 0. It also shows us right here. So we have 0 again. Then it's going to pick up where it left off. It's still not allowed to touch that 0 value, and then it's going up all the way up to infinity for our new graph. Again, don't forget to use your y for range and x's for domain. Now, just to get some language down, so you guys did this with your exploring activity just before these sets of notes. So standard form of a reciprocal function. You guys kind of started to notice this. So f of x or y equals, and we have an a divided by x minus h plus k. So some of you guys started noticing some things that were happening. Well, h is the horizontal shift, so this number right here, any number that is subtracted or added right there, is actually going to be your horizontal shift. Then, that one being a horizontal shift means that it's going to tell us whether it goes left or right. Since they have this negative right here, that negative sign is going to make everything go opposite. So that positive shift is actually going to go left. So if there is a positive sign right here, instead of a negative, it's going to actually shift left. If that negative sign there, there's a negative sign, it's actually going to shift right. So they go opposite the actual sign. The reason why they go opposite the sign, if you were to plug a -1 into that equation, a negative times a negative would be a positive. So it actually look like this. It would be x plus 1. So that's why it's going opposite, even though you plugged in that -1 value. Now, our k value is the outside shifts. So these are the ones that are going to go up or down. So these are our vertical shifts. So vertical, and then the positive actually really is going to go up. This one doesn't go opposite because that positive sign, and then this one is going to go down if it's a negative sign. Okay. So I'm just trying to write this a little nicer for you guys, so down. Okay, and then the letter A, the one on the numerator up there, that one, if it's a negative, it says if A is negative, the function is reflected. It's going to be across the x-axis. So the function is reflected across the x-axis. And I'll be showing you guys some examples of that as well. These little bars mean that the absolute value of A is greater than 1, which just means that it is positive. Positive as well as, actually not even positive. If it's greater than 1, it's just going to mean it's a whole number. That represents the vertical stretch. So this thing is actually getting widened out, it's stretching it out. Then if A is actually between 0 and 1, so being a fraction or a decimal, that represents a vertical compression. So it's actually squeezing it and making it compressed. So this is a compression. And then we have our vertical asymptote. The letter, we always write our asymptotes in equations. So this was x equals h. And then our horizontal is always going to be y equals, and it's the letter k. So these two letters actually tell us what our asymptotes are going to be, which is very nice. We just have to make sure we remember which one's which. And then again, I just wanted to write down for you guys, make sure that your graphs cannot cross these asymptotes. So go ahead and make that little star right over there, just so you remember that you cannot cross those asymptotes. Okay, so go ahead and write down these directions. This is the one set of directions for our next 4 examples. So you're going to graph each function, identify the domain and range, and the asymptotes. For our first example here, we are going to have our function f of x equals 1/2 x minus 2. We're going to eventually find our domain, range, vertical asymptote, and horizontal asymptote. So we see that we have a -2 out here. If we look back at our formula, we see that that represents the k. So what we're going to do is the k is always going to be our horizontal asymptote. So we have y equals -2. You always want to find your asymptotes first because that will tell us where to draw them. Now our vertical asymptote, we don't actually have anything else on that denominator representing our h with that x. So our x equals just 0. So let's go ahead and now draw our actual asymptotes so that we can visually see them. Make sure that you're drawing them as a dotted line. So with our x equaling 0, remember x equals 0 right here, well I have to draw a line going through that line so that it cannot cross that point right there, or that line right there. Now I also have another one at y equals -2. If you draw a point at y equals -2, you know you have to now have a line going through that point. So if that helps you realize where your asymptotes are, then go ahead and draw those. And these asymptotes would go on forever, meaning that we can never cross them in any of those directions. Now what's cool about these graphs is that we see that we still have our rise over run of 1/1. So we still get to do, we have no actual shifts. This is still representing our 1 over 1. So from the center now, where the asymptotes cross, right here, that's where I'm going to start counting up 1 to the right 1. So up 1 to the right 1, make your point there. And this is just going to go now continue out to here. It cannot cross that asymptote, and it should be a little curved, and it cannot cross that asymptote. Now we're going to go the opposite direction. So now we're going to go down 1 to the left 1 from that same point, and we have a point there. Now we get to extend our graph out forever. It cannot touch that asymptote, and again it curves a little bit and then starts going the opposite direction, not crossing that asymptote. Now we get to fill out our domain and range again. Well, our domain happens to be from negative infinity less than x, which is less than, so again we came from this side right here, you guys, and then we're still going in the x direction. Then all of a sudden I stop right here. I can't get past that x equaling 0, and again that shows you guys right here in your asymptote. So that's why it's so important to know our asymptotes. Then we continue on. We're still going from, now we pick up where we left off. We went from 0, and now we're continuing on, and we get to go all the way off into infinity. So that's just, again, your x value. So 0 less than x, which is less than infinity. Okay, now our range, we are starting from our lowest point to our highest point. So if we start from our lowest point of our graph, we see that it's going from the negative infinity side. So we're starting off from negative infinity still, less than y this time, and then we're going to keep going up. We're going to see that we actually get blocked right here. All of a sudden there's that dotted line of an asymptote, so that means that we have to actually stop with the values of our y equaling negative 2. So let's go ahead and finish doing our range, negative 2, and then we pick up where we left off again. Well, I get to pick up right here again and then continue off going in my positive y direction. So then the final part, negative 2 less than y, which is less than infinity. So our asymptotes help us really tell almost the whole graph. Let's go on to our next example. So this time I don't have anything on the outside like in my k area, in that area, but I do have something inside with the x. So remember that your h is the one that represents your vertical asymptote. So we have our plus 3 or positive 3 there. But remember, it's always going to be the opposite. So if we have that negative 3, it's the opposite sign, so you have to make sure your asymptote also goes negative. And then our horizontal, we actually don't have anything on the outside of our equation out here, so it's just going to be y equals 0. Now we're going to go ahead and graph those asymptotes so that we can make sure that we can actually graph our graph. Okay, and sorry, I forgot to put y equals 0. So now let's do our asymptote. So at x equaling negative 3, you go 1, 2, 3, put a dot there. I need a line going through. Remember it says vertical, so you're putting a line through there. And then my next one is y equals 0. Well, y equals 0 here, this is your horizontal one, so you need a horizontal line going through there. Now my slope still tells me 1 over 1. I still have a 1 in front of that x, I still have a 1 up here. So now from that center of that point, the center of my asymptotes is actually right here. So from that point, I am now going to go up 1 to the right 1, and then start my graph. And then I'm going to go down 1 to the left 1 in the opposite direction, and then start my graph. Okay, so the last thing we have to do, write our domain. Again, we're starting from the farthest point left. Negative infinity is less than x, which is less than, okay, let's see where we are getting eliminated. So we're starting from left. Oh, we get blocked by that blue right there, which was at negative 3. So now we are negative 3 here, and then we pick up right where we left off at negative 3, and then we're going to be going off into infinity again. So we skip that little section and then go right on over to infinity. And then my range, we're going to be coming from the lowest value, so lowest, and we're going to go up, 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 up until we hit that next asymptote, which is at 0 in this case. And then we're going to go from negative infinity less than, don't forget your y, 0, and then we pick up where we left off again and go all the way up into infinity of our y's again. So we go all the way up like that. So again, see how your y's go with your y's? and your x's go with your x's for your domain. All right, let's do our next example. So for our asymptotes here, we have a vertical asymptote at x equals 0 because I have nothing else with that x down here. And then I have, for my horizontal one, I have the 1 sticking out here that's positive, so y equals 1. Let's go ahead and actually draw those so I can make sure that I am hitting this correctly. Vertical asymptote this time, x equals 0. And then we have our y equals 1. Put a 1 right there, y, and now we're up here. Okay, you guys can totally use highlighters to make your asymptotes look very visible. Again, make sure you're drawing dotted lines. Now, we have a negative 4 over 1. So, let me show you what changes with our slope. Where we cross at, which was right here with our asymptotes, from that point we are now going to count down 4 and then to the right 1. So 1, 2, 3, 4, to the right 1. Okay? And then we are actually going to go in the opposite direction from this point as well. So let's go up 1, 2, 3, 4, and then to the left 1. Okay? What's nice about these slopes changing is that we can actually go another direction as well. So watch this carefully. Just sit back and watch this. I'm going to go to the right 1. Sorry, not to the right 1. I'm actually going to go to the right 4. So I'm going to try and see how, sorry, we have negative 4 over 1. And then so we already have these points from our slope. Well, we actually got to get to start doing more slopes. So we're going to change it up and go to the right 1, 2, 3, 4, but then down negative 1 so that we still have that slope. So it's actually just giving us a little bit more of an exact value of where this is actually curving. So this is curving a little bit steeper and not going all the way to that point. We can do the same thing. I'm going to, again, watch this slowly. I'm going to go 1, 2, 3, 4 to the left, which was negative, so that means I have to go up 1 to make it positive. And again, we're just going to kind of cross over here, make sure that you're not going across your asymptote, and see how it's actually a little bit less steep. The reason why it was less steep is because of this 4. So if we see back here, when our values, the a is greater than 1, it's going to stretch it out. So that's this value right here. It just stretched it out. So see how sharp these values are here, like on these little sections? Then that's what it just did. It made it way longer instead of super sharp. Okay, so let's go ahead and do our domain and our range. So our negative infinity, we're still starting from there. And then we do less than x, and then just look at your x value even. X equals 0, pick up where you left off, or sorry, not equals, but less than, and then goes off to infinity again. Same thing with your range. It's just going to be negative infinity to less than y, which is less than. Look at your y value of your asymptote, which is 1, and it's going to pick up where it left off again. Y is less than y, or 1 is less than y, which is less than infinity. All right, you guys, our last example here. So this is another one of the little bit harder ones that we just did. We should be okay with identifying our asymptotes now. So our vertical asymptote is x equals a positive 2. Remember, it's opposite that sign. And then we also have our y equaling a negative 2. That one stays the same. Now let's go ahead and actually graph our asymptotes so we can see how we're going to be graphing this. Go to your x equals a positive 2. Draw your vertical asymptotes there. Put your arrows, and then at y equals negative 2, we have a y equals negative 2. Go ahead and draw your horizontal asymptote at y equals negative 2. Now this is my starting point, that 0, 0 spot. I just literally shifted my origin, so I moved it from here to there. Okay, so now I'm going to start counting. So I see I have a negative, I'm sorry, not negative, I have a 3 over 1 still. So we're going to do this in both directions again. So from that center point, I'm going to go up 1, 2, 3 to the right 1. And then I'm also going to go from this point to the right 3, 1, 2, 3, and up 1. So this is my stretch again. The reason why I know it's stretching is because that 3 is a whole number and not a fraction. And then I'm going to go the opposite direction, negative, negative. So from this center, I'm going to go down 1, 2, 3 to the left 1. Negative divided negative gets me positive. To the left 3, down 1, gets me another positive, and I have a stretch again. Okay, so that's your, let's just finish the domain and range. Again, we go from negative infinity, less than x, which is less than, go to your x value, which is 2, and then pick up where you left off, which is 2 less than x, which is less than infinity. Now go to your y, negative infinity is less than y, which is less than negative 2, and negative 2 is less than y, which is less than infinity. Okay, so that's our recap. Let's do a little recap, you guys. So for the essential question, you need to give the reciprocal. If you were given a function in standard form, or for a reciprocal function, which letter represents the vertical asymptote and which letter represents the horizontal asymptote. So I want you guys to go back and make sure that you are able to answer that essential question now. And then just to refresh, make sure that you guys are really familiar with the shifts right here. So this is the graph, this section, this slide, it should be the one that you guys should really start helping you, because that's going to help you with your shifts for all of your graphs. All right, you guys, I'll see you next time.